Hello, my name is Cecilia Reed, and this is my first lab report for Physics 2212 regarding the buildup of charge on everyday objects. The purpose of this lab is to determine the excess buildup of charge on Scotch tape and to observe the behavior of charged products. I first went through the experiment and then fit the experiment to GlowScript. We were also asked to find the net charges on the tapes, which came out to be 9.33 times 10 to the negative ninth coulombs. The major concepts present in this experiment, which allowed us to calculate the results, were Coulomb's law, the definition of an electric field, force on a charged object, Newton's second law, and force due to gravity on an object. The principle of like charges repelling and opposites attracting was also used to derive my results. This is demonstrated through the equation showing the laws and formulas for the concepts listed. One can see that since F net is 0 for this experiment, the electric and gravitational forces are equal and opposite to each other, which can be plugged into other equations to find the charge of the tapes. The principle of like charges repelling was integral to this lab because it allowed us to determine the charge of the U-tapes by observing its behavior near known charges. Also important to ensuring that the results were not skewed was the test to see that if the tapes were attracted to neutral objects. To begin this experiment, I measured out a piece of tape that was 20 centimeters long or 0.2 meters long. I created a little handle at the end for ease of cleaning and stuck it to a desk. I then measured out an identical 0.2 meter tape, created a handle, and stuck it on top of the other tape. I quickly ripped off the top tape called the U-tape off in order to charge it, and repeated the same process in order to create a second U-tape. I tested to see if the U-tapes were charged by holding them near my hand, which was a neutral object. I held the two U-tapes towards one another to make sure they were still charged, and I charged a plastic pen by rubbing it on my hair and held it up to the U-tape to determine if it was positively or negatively charged. Finally, I placed one of the U-tapes between two tables and began to slowly move the other U-tape closer to it. I stopped when the top U-tape began to float and measured the distance. This particular part of the experiment allowed us to calculate the excess charge on the tapes. First, we had to make some clarifying assumptions for our calculations. For the calculations, I assumed that each U-tape had the same net charge and also that it could be represented as a point charged. The observations that I made during the lab were that the U-tapes were attracted to neutral objects like my hand and that they repelled each other, indicating that each U-tape had the same charge. The U-tape was also attracted to the negatively charged pen, indicating that it is positively charged. I also observed that the top U-tape began floating at 0.02 meters. Next, I performed my calculations starting with the gravitational force, which is equal to the electric force in the y direction, since it was not moving, and F net was 0, and that came out to be 0.00196 newtons. This allows us to solve for Q by plugging in the numbers that we have. Charge on the U-tape came out to be 9.3 times 10 to the negative ninth coulombs. If you divide the charge on the tape by the charge of an electron, you can calculate the number of deficient electrons, or excess electrons, which was 5.83 times 10 to the 10th. To calculate the fractions of atoms that gave up electrons, I found the surface area of the tape by multiplying length and width, and divided the area of the tape by the area of an atom, which yielded 1.46 times 10 to the negative 7th atoms that gave up electrons. The ratio of electrons to atoms was 1 to 6.86 times 10 to the 6th, or 1.46 times 10 to the negative 7th. I used this GlowScript code to model my experiment, which produced this representation, with the cyan arrow representing Fe and the orange representing Fg. As you can see, they're equal and opposite in charge, meaning the F net was 0, which helped us with our calculations. So what if the electrons were positive and protons were negative? Would my observations change? Nothing would change because like charges still repel each other. Everything would still behave the same way as the U-tapes would still repel each other, and the numbers would remain the same since protons and electrons are equally and oppositely charged. The only technical change would be that we would label the U-tape as negative instead of positive. However, it would still describe the charge as being opposite of the charged pen. Why is it important to handle the tapes as little as possible? Because touching them neutralizes the charge buildup and ruins the experiment, and it ruined mine several times. We handled the tapes as little as possible to avoid neutralizing the charge. Thank you for listening to my project.